are hilly terrain, some are peneplain terrain, some are terrain which contains hill as well as the flat land. So all these different variations of the terrains which are actually supplying the sediment depending on the climate, the area of the drainage basin, the elevation of the terrain, how the sediments they are basically generated, and how we do the basin analysis in terms of the sediment budgeting, the accommodation in the basin, the denudation on the land. So all these they are in a basket. So this exactly is what is called the basin analysis. We initially discussed that how the basin that gets formed, what is its thermal subsidence, what is its mechanical subsidence, and how then the water and the sediment load that cause the further subsidence. What are the different types of subsidence curve, how accommodations are generated in the basin, and then we discussed that how it actually accommodates the sediment. What is the amount of budget of the sediment that is being formed, and then how it is accommodated in the basin. I think this portion I could transfer to you in a reasonable way. Now today, the topic what I was thinking of discussing finally, that as a geologist, when you are assigned a work, suppose you have joined to GSI, joined to ONGC, joined to AMD, here anywhere, and then you are sent in a basin to for any kind of exploration program, that you have to have a mineral exploration program, a hydrocarbon exploration program, you are sent to that. Then where to start the work, how to start the work, how you try to understand that I am working in this kind of a basin, I am working in the passive margin basin, working in an intercatonic sack basin, working in a poleland basin, working in a reef basin, how I get to know, because ultimately when I am sent to a basin, then it is either a rock succession or it is a subsurface succession. Okay, so it is a rock. I am working in a Permian basin, working in a Carboniferous basin, working in a Triassic basin. How I do know that I am working in which tectonic setting, and what kind of application I have to do in this kind of basin to make the final model that then people do. Suppose hydrocarbon exploration, you go, then the company asks you, where is the reservoir, where is the source rock, what is how the source rock is getting mature, and which level of the subsurface I may get the reservoir. You have to tell me everything. If you go for the mineral exploration, then people ask, what are the typical, is it a stratigraphically controlled or it is a structurally controlled? If it is a stratigraphic control, how the mineral bearing fluid that has been invaded, is it a syngenetic ore, it is a diagenetic ore, or what it is? So you have to understand how really the entire basin in a syngenetic stage or a post-genetic stage, how it really behaves. Some of the best example, suppose the lead zinc deposit of Zawar, which is a carbonate hosted lead zinc. Now you have to understand that when the mineralizing fluid that has been invaded the carbonate rock. So all these are questions that suppose you are working in a hydrogeology. So water resources. Now in the water resources, you have to understand that where is the aquifer. Now is it a confined aquifer? Is it unconfined aquifer? Then what is the under subsurface lithology? How this subsurface lithology that has been behaving? What is the lateral and the regional extent of the reservoir? And how it is behaving? Is it a fluvial channel? Channels are behaving as a reservoir, or it is a delta that the transitional environment reservoir. All these are the knowledge that you require for any kind of exploration, mineral exploration, water exploration, hydrocarbon exploration. Okay. Now, for hydrocarbon or water on which we live, actually, we live, water on live, all these are you get only in the sedimentary rock. You do not get it in igneous or metamorphic rock. Do you get water in the metamorphic rock, in the igneous rock? No. Can you live without water? No. So try to understand the importance of this sedimentary rock and the understanding of the entire saga, that how we do the basin analysis. Okay. Now there are some basic thumb rules. These thumb rules from which a sedimentologist or a basin analyst, they start doing the work. So they construct some kind of map. Those maps help us to identify and to interpret some original peculiarities of any basin, which help us in interpretation. So what are the maps that required to be generated before we proceed to the more intricate and more high resolution studies that I have already discussed with you, that the how do we do the basin modeling and all this. So some maps that I will be discussing today, which help us in understanding the tectonic background of the basin, as well as the type of analysis I have to do for that particular tectonic setup of the basin. Now, what are those studies? What are those maps that basically help us in doing so? Number one, structure contour map. Number two, isopath map. Number three, subcrop or worm eye view map. Number four is, this is also called paleogeographic map. This is called paleogeographic map. Number four, clastic ratio map. Number four, clastic ratio map. Number five, stratigraphic correlation map. Stratigraphic correlation map. Number six, paleocurrent map. Paleocurrent map. Okay, all these different kind of maps in the basin that basin.
What is written before I? The third number, subcrop or
one IQ, one.
Okay.
One IQ map. Okay. Now, what these maps do? These maps help us to identify that how the different formations, basically sedimentary units, they are distributed in a basin. Where is its maximum thickness? Where it is tapering out or wedging out? Then from which side of the basin the sediment is basically carried and it is being transported from which side, and which is the distal part of the basin? What is the, was there any depositional high prior to the deposition of the sediment? There is a depositional high, there may be a deposcenter, depositional low. Okay, so all these, there may be the domes, there may be synclines, all these things that we come to know that this is actually the disposition of the sediment and the disposition of the sediment with respect to the entire basinal scenario. We'll discuss one by one to this. First, we start with structure contour map. You all know that what is a structure contour map. Okay. Now, structure contour map, how it is constructed when you draw a structural contour map. What is the premise? How you are basically assigning that this is this elevation, this is this elevation, this is this elevation. How you do that? Hello?
Sir, on the
Yes.
basis of the scale, the points of equal elevation are joined together to form the contour.
Yeah, you know, actually what you do, you require a mean surface, and that is sea level, isn't it? Or there is a mean surface which is called the base level. With respect to that, the different location, what is the elevation of that location? Am I correct?
Yes, sir.
What is called the RSL, relative sea level, or reduced sea level. Sorry, not relative, reduced sea level. So what is that? That actually what is the elevation? If I take the distance from the center of the earth to the top of a hill, and then subtract from that, from the center of the earth, the distance up to the sea level. Am I clear? What is reduced base level, reduced sea level? What is reduced level? RL. What is? You will see in different rail station in the board that is written RL. What is RL? Hello.
So reduced level.
Yeah, what is that? Why it is reduced? Why it is called reduced? It is reduced because it is a distance from center of the earth to that point, to that station, minus center of the earth to the sea level, or the sea level. So it is reduced. The level that is with respect to the center of the earth, that is the reduced. You understand what I am saying?
Yes,
Yes,
sir.
sir.
ये सब ये इंटरव्यू में पूछते हैं एक्चुअली. What is the meaning of reduced level? Now, this reduced level, now based on the reduced level, you actually make a structure contour map. Fine. Now, this structure contour map, that is basically done both on the outcrop as well as in the subcrop. We do it for the subcrop as well. How we do it in the subcrop? In the subcrop, this structure contour map is done from the seismic data. From the two-way travel time data of the seismic wave, you transform that two-way. So what if I draw
Sir, can you change the marker? Because the diagram is not properly visible.
You know, till today I have purchased about 1,000 rupees pen for teaching with no help from the university. Can it be visible now?
Yes, sir, better.
I don't know. देखते हैं कई सारे पेन अभी एक्चुअली खत्म हो गए. तुम लोगों को कुछ आइडिया है कब तक खुलेगी यूनिवर्सिटी?
सब नेक्स्ट सेमेस्टर से बोल रहे थे.
नेक्स्ट सेमेस्टर
बस पता नहीं.
अच्छा. अभी शायद दिखाई दे रहा है.
Yes.
Yes, sir.
नहीं इसमें कोई ये नहीं है. Actually, what I was trying to show you that there are this kind of situation that when you draw this kind of diagram, then you come to know where is a dome, where is a syncline. So all these things that you come to know. This is a structure contour map. This map can be for a outcrop level or it can be for a subcrop level. Subcrop. Now, in this subcrop level, what happens? Suppose this is your surface, and you want to make a contour map for a reflector in the subsurface. For a reflector, this reflector may be the contact between two different lithologies. You are trying to map this reflector. So, what is happening that there is the seismic wave that is passed and there is two-way travel time. This is traveling and going up. So there is a time which is called two-way travel time. This will be actually taught in your next semester in geophysics. Okay? Hello?
Yes, sir.
Yes.
Yes.
Yeah. Either Dr. Shakib or Dr. Shakib or me will together we will try. So this time is then transferred to depth, and that depth is basically plotted there. So it can be done both on the surface and what you get from. So if I make a map of this subsurface by means of this seismic two-way time and corresponding depth, okay. So there I can identify a paleo high. What will happen? That here the time that will require, that will be less than the time it will require here. So this time when you will be this time into velocity, when you will be doing the time into velocity, you get the distance, and that distance, if it is less than this, then you know this was acting as a paleo high. So this paleo highs during the deposition that can be identified. Similarly, somewhere if a formation it has a exceptionally high thickness, then you identify it became a depocenter at that time. So where is the depocenter? Where is the paleo high? That can be identified by means of the subsurface. This drawing of this one. Is it okay?
Yes, sir.
Okay. Then we come on to the isopac map. Now, what is isopac map? Isopac map is the thickness map of a particular formation. So, what is the thickness of a particular formation, and where you get the maximum thickness and where you get the minimum thickness. So that gives you idea that which part it is the deeper part of the basin and which was the shallower part of the basin. Suppose I have made a, sorry, you are basically making an isopac map, and depending on the equal thickness point, you are drawing the contour, equal thickness point. What you are seeing that for a sandstone horizon, you are doing the isopac map, you are seeing that the 12 meter is the contour line here, and then you are getting 2 meter and there is no formation. What does it mean? The entire sandstone, so I may have a basement, so it may be basement, and the sandstone, it is being deposited like this. So this is the sandstone, and so when you are doing so this is the area, you are doing the map, then you are getting no formation here, and from 2 meter to it is going to 12 meter. So you get the feeling what is the direction and what is the direction of deposition of a particular formation, and in which direction it will be wedging out. Okay, fine. Then we go to paleogeographic map. What is paleogeographic map? Paleogeographic map is seeing any formation from above or below. Seeing any formation from above or below. What does that mean? What does that mean? That I want to make the map a particular level. Now, suppose there is now this is a succession, and in this succession, this is a limestone. This may be shale, this may be silty shale, this may be sandstone, this is sandstone, silty shale, all these different things are there. Now this is the horizon what I am looking for, because this may be mineralized or hydrocarbon there. This is a limestone. I want to know in full what is the geometry of this limestone, where the limestone unit is thicker, where the limestone unit is thinner, how the limestone unit in the regionally it is behaving. So I want to map the limestone, and it may be at about 1.5 kilometer, 2 kilometer depth, and then before the exploration, your company asks you to totally tell them how the limestone over, suppose it 25, 30 square kilometer area, 40 square kilometer area, 100 square kilometer area, how this limestone is behaving. You have to tell them. Then, what is our idea? That we have to see this limestone from top. By removing all this, I have to see the top of limestone, how it is. Or by removing underlying this, I have to see it from below and see how the limestone is from below. You got my point?
Yes, sir.
If I see it by removing top and seeing the top of limestone, that kind of map, I call it subcrop map. Subcrop map. And when I remove this and see it from below and how the limestone, when I map it, I call it worm eye view map. Worm eye, as if like a worm, I am seeing it and trying to map it. Worm eye view. Okay? How do I do it? I do it, as I said, by the seismics. By the seismic, and these two maps help us to identify in totality that subcrop map and from the one my view map that how really the unit I am looking for, it is varying in the space. Varying in the space. Fine. Then we go to clastic ratio map. Plastic ratio map. What is plastic ratio map? We make a ratio sandstone plus conglomerate plus shale divided by limestone plus dolomite plus evaporite plus coal. This ratio, sandstone, conglomerate, shale, divided by limestone, dolomite, evaporite, coal. This ratio is determined. So the clastic by chemical, this ratio is determined, and then the equal ratio points are joined to make a clastic ratio map. Am I clear? That
Sir,
from-
please recollect.
Hello. No, this is a clastic ratio. What is clastic ratio? Sandstone, conglomerate, shale divided by limestone, dolomite. So you are comparing the terraneous divided by chemical. Now this ratio, if I get several points in a area, this ratio is determined. Then the equal value, they are joined. Equal values are joined. Equal values are joined. And from high, we get the high to low. So this is a high plastic ratio value. This is low plastic ratio value. So that means this is the shallow part of the basin. Then you are going to the deeper and deeper part of the basin. Am I clear?
Yes, sir.
Yeah. This is also done. This is also done. This is one way. The other way of doing this thing is by means of the lithopesis mapping. Lithopesis mapping. What is that? That also does the same thing. Suppose I make a triangular diagram. Limestone, sandstone, shale, 75. $25. Okay. So now this is totally limestone. This is shale. This is sandstone. This may be sandy shale. This may be shelly sandstone. This is another. You get? So these three different. Now, based on that, we then map it by classifying the entire. This may be the sandstone is to share 1:1. So you can have a, this may be a sandy shell, that is shelly sandstone. This may be a limey shell, limey sandstone. You got my point? Hello? Have you drawn it?
Yes, sir.
Okay, so I think you could get me what I am trying to say, that whether I do a plastic ratio or I categorize the different blocks in terms of the triangular diagram, and then either by plastic ratio or by triangular diagram and understanding that which lithology in which type, this is what is called the lithobasis map. So lithobasis map or the plastic ratio map, they do the same purpose. They just allow us to understand what is the proximal part, what is the distal part, how the different lithologies they are being distributed, what is their mutual relationship, and all these they basically try to make us to understand. Then we come to the stratigraphic cross section. Stratigraphic cross section, and from the stratigraphic cross section we try to understand the lithological relationship. Lithological relationship in space-time frame. In space-time frame, the lithological, what we call the Penn's diagram, what we basically refer to as the Penn's diagram. So what you are doing here, you are basically taking a, either it is a litholog or it is a well log. When you are doing it in the outcrop, there is a litholog. When you are doing it for a subcrop, it is a well log. So litholog or well log, then the well log is interpreted in terms of lithology. The well log can be, it can be the self potential log, the resistivity log, the gamma log, all these different kinds of logs are there. They allow us to interpret the different litholog. And then it can have a litholog which is on the base of the outcrop. Then you have an outcrop, litholog, and then you try to match the two sides and make, and then this I have drawn for a 2-dimension. It can be 3-dimensional as well. It is like a fence. In the like a fence, you understand the different lithology and their mutual relationship. Suppose I consider that this is water bearing. This limestone is water bearing. Now, one person is drilling it here. He get a huge thickness of the limestone. Some person who is drilling here, he is only interacting this much portion of the limestone. And a person who is drilling here, he has to drill a huge thickness to reach to the limestone. You understand? Then why a person who is drilling here, he will drill so much to reach to this if he has any other alternative source. Who will tell them? Who will tell them? You have to tell them. It may be a case of water bearing, it may be a case of the hydrocarbon bearing. So, if somebody gets this much of thickness at a very shallow level, it doesn't mean it will be repeated in the same way in other parts of the basin. How I know that whether it will be the same way in the other part of the basin and not same way in the other part of the basin? This is a typical action that is being done, that is the fence diagram reconstruction, which allow us to tell that what is the direction of how the different lithologic units they will be behaving. Okay, is it clear? Hence diagram. Hello.
Yes, sir.
Okay. And then finally, what we do, the last what I wanted to discuss, that is the paleocurrent. The paleocurrent. This I have discussed in your sedimentology course also when I discussed the paleocurrent. Now, paleocurrent is a very, very important what we identify from the scalar attribute and the vector attribute. Both scalar and vector attribute, they allow us either in a regional scale or in a very local scale what is the direction of the paleocurrent. So if I have suppose I get a elevation, I get a dome, this is the elevation, and the paleocurrents are diverging away. That means, what is that means? That this high remained as a barrier for deposition and it controlled the deposition. Because of this high, that the flow got diverted on both sides and you are getting the paleocurrent diverging from that. This is a typical, so you can identify that there was a basement high and that basement high actually controlled the sediment dispersal process. Or you may have, there is a high, but the paleocurrent has no control. Paleocurrent cut across that high. And when I am measuring the paleocurrent, I am saying that there is no control of the high. The high I am getting, but paleocurrent has no control. What does it mean? That the sediments were deposited early and then it was deformed and it forms an anticline. And that's why paleocurrent has not no relation to it. Because the high was not there when it was deposited. The high was formed after the deposition and then there is a deformation of the rock and the anticlinal high has been formed, but the paleocurrent has no role of this. So a basement high which is controlling the dispersal pattern or a subsequent deformation and the anticlinal high which has no relation with the paleocurrent. This helps us to identify when the deformation, when the high was formed, whether it controlled the dispersal pattern, whether it does not control the dispersal pattern. Am I clear? Is it any doubt? There is any doubt? Hello? Hello?
Yes, sir.
Is there any doubt here? How paleocurrent help us to identify that whether there was an original basement high which controlled the dispersal pattern or that paleocurrent has no relation, though there is a has no relation, because the deposition, after the deposition, the deformation has created an anticlinal structure and that now we are getting in the form of a high.
Yes, sir.
Okay. So these are the different techniques what people follow, and by that they try to understand what is the different roles that has been played in the sediment distribution, what is the pattern of sediment distribution, whether there are multiple depositors or there is a proximal to distal relationship, and all these that help us to identify what kind of tectonic setting we are working, and that help us in the tectonic modeling of the basin. Tectonic modeling of the basin. Now, this is what I thought of discussing. If you that day Trideep asked one question. What was the question?
I was telling that can you discuss the application part of the sequence stratigraphy?
Application part of sequence stratigraphy.
Yes.
Okay. Let me first tell you a statistics. Sequence stratigraphy was introduced by Exxon Group in 1988. The first paper, which was a professional paper from the Exxon Oil Mobil group, which was the Van Wagoner, Posamentier, Walker, all these people, they were there. And they combinedly wrote the first professional paper on the concept of sequence stratigraphy, which totally changed the subject. After the sequence stratigraphy was introduced, this is not that I am telling. This is a fact which is even if you search from the Book of North, you can get it. That before the advent of the sequence stratigraphy, if you tell me that in the world, the oil and gas reservoir, what is the percentage of sandstone being a reservoir for oil and gas? Any idea? What is the percentage of sandstone that is sandstone acting as reservoir for oil and gas? Any idea?
No, sir.
50% of oil reservoirs in the world are sandstone, and 75% of the gas reservoirs of the world is sandstone. Okay? So 50% of the oil reservoir is of carbonate. So the oil reserve is equally shared by the carbonate and the sandstone. Whereas gas reserve, 3/4 of the gas reserve is in sandstone, 1/4 of the gas reserve is in limestone. This is the world average distribution. Now, when all our ideas of this oil and gas, that was actually in the form of structural trap. That we get the oil and gas deposits from the structural trap. And what is the difference between reservoir and trap? Any idea? What is a reservoir and what is a trap? पेट्रोलियम कोर्स हो गया? हेलो,
So चल रहा है semester.
चल रहा है. तो what is a reservoir and what is a trap? क्लियर है ये चीज?
So in the reservoir, the oil accumulates from where we extract the oil. And the trap is kind of formation that traps the oil from the spilling.
नहीं, दोनों चीज तो एक ही है ना. तुम जो है from we extract the oil and where from trap. So what is the difference between reservoir and trap?
So porosity और permeability का difference होता है
दोनों में.
So reservoir rocks have good porosity and permeability, whereas trap rocks are least permeable.
Trap rocks
So
are
they
only permeable.
So least, yes, sir.
The movement is possible in the reservoir, and in traps it is not possible.
Traps removal not possible. All definitions are wrong actually. What is a reservoir? Any rock which has a property of proper porosity and permeability. That is a reservoir. What is the unit of porosity?
So it is dimensionless. Measured percentage.
Okay, very good.
Yes, sir.
So any rock which has the proper porosity and permeability, I will call it a reservoir rock. But having porosity and permeability does not mean that it will have oil. If I have no source rock nearby, if there is no migration of the oil, then even if I have the reservoir quality, I will not be having any oil. And what is a trap? When a reservoir rock has physically trapped oil, then you call it a trap. Am I clear?
Yes, sir.
When ये definition clear कर लो, हालत खराब हो जाएगी तो कोई भी इंटरव्यू में.
So what does physically trapping means? That
ऑयल
reservoir
आया है भाई वहां, वो ऐसे बैठा है, ऑयल आया नहीं है, ऐसा नहीं है. ऑयल जहां पर फिजिकली ऑक्युपाइड द पोर स्पेस, दैट इज कॉल्ड ट्रैप. बट ऑल traps are reservoir, but all reservoirs are not trap. Am I clear? Hello?
Yes, sir.
Yes, sir.
Reservoir is a quality of a rock unit, whether it is a sandstone or a carbonate. Reservoir is a quality. Now, whether my quality has been utilized, that depends on other factor, that whether oil is really coming to them. Okay, and all, and जो तुम कह रहे हो ना, what you are, ये जो permeability नहीं, तुम कैप रॉक की बात कर रहे हो. कैप रॉक पे permeability नहीं होती. Both reservoir and trap, they have the good porosity and permeability. Anyway, I am not going into that. तुम लोग, you have the different course, तुम वहाँ पढ़ लेना. Now, what I am saying, that after the sequence stratigraphy is introduced, the stratigraphic trap identification has increased about 35 to 40%. Before that, people only believed that the structural traps are the only source of oil and gas. And there were no appreciation for the stratigraphic trap. That when we talk about sequence stratigraphy, we talk about forced regression, we talk about the deep water reservoir and the forced regression, and then the forced regression and the related deposit in the deep water, those are the stratigraphic traps. The one example I am telling you, that the largest gas reserve of the Reliance, that is DK6 in the Krishna Basin, Krishna Kaveri Basin, the DK6, that is a channel deposit onto the shell. So all these concepts that the sequence stratigraphy that will give you, that to identify that where will be the reservoir rock, where will be the seal rock, where will be the source rock, and how it will be distributed in the form of forced regression, the transgression, and the high stand, that how, when the deltas will be formed, how the deltas that will be capped by the transgressive system in the form of estuarine sediment. All these are concepts which are inherent in the basin analysis and the hydrocarbon exploration program. Is the backbone of the oil industry is the sequence stratigraphy. Is it okay?
Yes, sir.
Yes, sir.
So there are large number of uses that the sequence stratigraphy is fundamental in understanding the depositional history. Now, when the oil will be formed, when you have a source rock, that means the shale with proper organic carbon, the proper kind of the material which can be cooked, When the oil will be formed, when the H/C ratio will be high, O/C ratio will be low. You must have read the Van Crevelen diagram and the H/C ratio, O/C ratio. And then that should be matured about 90 to 125 degrees. That should be matured, cooked with proper period of time. How you know that whether it gets cooked? The subsidence history, the thermal history of the basin, that at what time plane, the residence time, all these are interrelated. At what rate the basin is subsiding, and that basically increase the temperature, and that help in the cooking of the source rock. All these are concepts of sequence stratigraphy. Okay.
Yes, sir.
Okay, so let us call it a day. I have a meeting at 11. Someone must have maintained the attendance, isn't it?
Yes, I guess Ankita is doing that.
Okay, so attendance भेज देना मेरे को. And with this we are.
Excuse me,
Hello.
Sir, there is a problem in the form fill up. So we are not able to submit it. Sir.
Form fill up, what problem?
So all the
An
subjects are not
examination
showing.
form.
अच्छा ऑनलाइन नहीं हो पा रही है.
सर सब्जेक्ट शो नहीं कर रही है सर, मतलब इलेक्टिव ओपन इलेक्टिव.
अच्छा लास्ट डेट कब है?
आज ही है.
आज ही है.
यस सर.
Okay, let me see. I will do something. Okay.
And sir, basin analysis part के लिए कोई book suggest कर दीजिए.
You can consult the book of Ensele, EINSELE, Ensele.
Okay, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.